Efficiency is equal to mechanical advantage over velocity ratio times 100%. Mechanical advantage is equal to load over effort. Velocity ratio is equal to 2 pi a over p, where a is the radius area, p is the distance of the pitch. Velocity ratio is equal to, by substituting the values, we have 2 times pi is 3.14 times the radius area, which is 0.21, all over the pitch, which is 0.002 meters, which gives us the velocity ratio of 659.4. Then we know that from the formula of efficiency, E is equal to MA over VR times 100%. Then our efficiency is 50 divided by 100, which is equals to MA, which is not known, over the velocity ratio, which is 659.4. Making mechanical advantage the subject of the formula, we have 50, which is the efficiency, times velocity ratio, which is 659.4, all over the percent, which is 100, which will give us our mechanical advantage to be 329.7. But mechanical advantage is still equals to load over effort, P. Therefore, our mechanical advantage is 329.7 is equals to the load is 8,800 all over the effort, which is not known. Making the effort the subject of the formula, we now have 8,800 over 329.7, which will give us our effort to be 26.7 Newton. Question 7. A ball of mass 0.5 kilogram moving at 10 meters per second collides with another ball of equal mass of rest. If the two balls move off together after impact, calculate the common velocity. Solution. Momentum before collision is equal to m1u, which is equal to 0.5 times 10, which will give us 5 kilogram meters per second. Momentum after collision is equal to m1u, which is equal to m1 plus m2, all in times by v2, which is equal to 5 is equal to, that is momentum before collision is equal to momentum after collision, which is equal to 5 is equal to 0.5 plus 0.5, all in bracket v2. Making v2 the subject of the formula, you now have 5 over 1, which is 5 meters per second. Question 8. A machine gun with a mass of 5 kg fired a 50-gram bullet at a speed of 10 meters per second. Calculate the recoil speed of the machine gun. Solution. Momentum of the gun equals to momentum of bullet. mg vg is equal to mb vb. Therefore, mass, which is 5 of the gun, mass of the gun, times velocity vg, which is not known, is equals to the mass of the bullet, which is 0.05, times the velocity, which is 100 meters per second. Therefore, making vg the velocity of the gun the subject of the formula, we have vg equals to 0.05 kilogram times 100 meters per second, all over 5 kilogram, which will give us 1 meters per second. Therefore, recoil speed of the machine gun is 1 meters per second. Question 9. A rocket burns 0.01 kilogram of fuel each second and ejects it as a gas with a velocity of 5,000 meters per second. What force does the gas exert on the rocket? Solution. force is equals to mass of gas ejected times its velocity, which is equals to 0.01 times 5,000, which will give us 50 Newton. Force exerted by the gas on the rocket is equal to 50 Newton. Example 10. A thermometer has its stem marked in millimeter instead of degrees Celsius. The lower fixed point is 30 mm and the upper fixed point is 180 mm. Calculate the temperature in degrees Celsius when the thermometer reads 45 mm. Solution. The diagram reads the upper fixed point 180 mm to be 100 degrees Celsius and the lower fixed point 30 mm to be 0 degrees Celsius. The x is the millimeter, which is unknown. Using the interpolation technique, 45, which is the diameter where the s degree minus 30 all over 180 minus 30, which is equals to x minus 0 all over 100 minus 0, which is equals to 15 over 150 is equals to x over 100. Making s the subject of the formula, we now have 15 times 100 all over 150, which will give us 10 degrees centigrade. Question 11. The pressure on the gas of a constant gas thermometer at the ice point is 325 mm of mercury, and that of the steam point 875 mm of mercury. Find the temperature when the pressure of the gas is 490 mm of mercury. Solution. Tp is equals to P1 minus Po all over P100 minus Po times 100, where Tp, Po, P100 are temperatures at T degrees centigrade respectively. Therefore, Tp, which is equals to 490 minus 325 all over 875 minus 325 times 100 degrees centigrade, which will give us 30 degrees centigrade, which is now equal to 30 degrees centigrade plus 273, which will give us 303 Kelvin. Question 12. Dry hydrogen is trapped by a pallet of mercury in a uniform capillary tube closed at one end. If the length of the column of hydrogen at 27 degrees centigrade is 1.0 meter, what temperature will the length be? 1.20 meters. Solution. From Charles' law, V1 over T1 is equals to V2 over T2. Since the tube is uniform, its length is proportional to volume. V1 is equals to 1.0 meters cube, V2 is equals to 1.20 meter cube, T1 is equals to 27 degrees centigrade plus 273, which gives us 300 Kelvin. T2 is unknown, therefore substituting the value, we have 1.0 over 300 is equals to 1.20 over T2, making T2 the subject of the formula. Therefore, T2 is equals to 1.20 times 300 all over 1.0, which gives us 360 Kelvin. Therefore, T2 in degree is equals to 360 minus 273, which gives us 87 degrees centigrade. A